Have you ever wanted to clone yourself? Just think, you could hang out with your friends while your clone did your homework and chores. You might not be able to clone yourself yet, but some cells of your body can clone themselves. One type of cell that can clone itself is a B cell. B cells are part of your disease-fighting immune system, and they reside in the bone marrow. They can travel around the body, and when disease strikes, B cells respond by creating antibodies. Antibodies, abbreviated AB, are proteins that attach to invading bacteria and viruses and tag the invaders for destruction. Think of darts. You throw a dart at a dartboard made of a specific material and it sticks. If the dartboard was made of another material, the dart wouldn't stick. Instead, it would just bounce or fall off. Antibodies are the same way. Each antibody is made for a specific surface. Velcro darts won't work on a regular dartboard, and regular darts won't work on a Velcro dartboard. The surface an antibody sticks to is called an antigen, abbreviated AG. Each B cell has its own unique antibody that attaches to a specific part of invading diseases. The B cells with antibodies that can attach to the invaders are told to begin cloning themselves. The clones will only make the antibody produced by its original B cell. In this way, B cells create clonal antibodies. When your body fights infection, it produces polyclonal antibodies. Polyclonal antibodies are like the little yellow minions in Despicable Me. They're all a little different, but they help in the same way. Polyclonal antibodies are made from the clones of many different B cells that recognize different parts of the same invader. In research, scientists often use polyclonal antibodies to identify parts of unknown molecules. Polyclonal antibodies are useful because even if a virus or bacteria changes its structure just a little bit, the antibodies will be able to find and attach to it. To make polyclonal antibodies, scientists first inject antigen into an animal, usually a sheep, donkey, or rabbit. The animal then makes antibodies to that antigen. Scientists collect the antibody from the animals using various scientific techniques. When B cells see an antigen again, they clone themselves very fast and send out armies of antibodies. So the animal is given the antigen again, and scientists are able to collect even more antibody than the first injection. The collected polyclonal antibodies are used in scientific research and can even be used in disease diagnosis. The downside of polyclonal antibodies is that sometimes they not only recognize the bacteria or virus, but other unrelated molecules. Antibodies produced by the clones of one B cell are called monoclonal antibodies. You can think of monoclonal antibodies as the stormtroopers in Star Wars. Each one looks exactly the same and does exactly the same thing. Monoclonal antibodies are highly specific. They're often used to identify disease agents and look at changes in body